Hey everybody, welcome to Chapter 9, Transformations. This is my third take on trying to record this video. First one kind of stunk, second one went 20 minutes, and so I'm going to let you pause and read this and take it down, and then we're just going to move on. I'm going to try and make this as short as possible. It's not that complicated and shouldn't take 20 minutes. I got to do a better job here. So here we go. Ready? Go. First of all, a transformation is a change to a geometric figure. It's a function or a mapping that results in a change in position, size, or shape of the figure. So got all kinds of pretty stars. Some are different, are scrunched up, some are turned, some are slid, some are changed in size. These are all different kinds of transformations. We're going to start easy with three specific transformations in these first three units of the chapter. And they are called rigid transformations because they maintain an object's size and shape. All angles stay the same, all distances stay the same, and there are three kinds of them. Okay, we could take this shape, this little Yuma shape, and we can just slide it into another position. That's called a translation. We can take that shape and we can reflect it, like turn it backwards. That's called a reflection. Okay, or we can turn it, which is called a rotation. All right. Sometimes we do a combination of these and still maintain the same size and shape. But in any case, every one of these we're going to have, we start with what's called a pre-image. That's the image we start with. There's your pre-image. And after we've done a transformation on it, we call that the image. Okay? So pre-image, transformation, image. Pre-image, image, etc. Okay, let me go through those once again and show you how they're going to work. The three that we are talking about. We can take this Yuma figure here and we can take it and turn it. Okay, that is called a rotation. Okay, we can just turn it all kinds of different ways here. All right, rotation. Rotation. We could also take this image and flip it. Okay, let me do this. I need to transform it by flipping in the y-axis. All right, there's our reflection. And finally, the one we're going to talk about today, we'll get to the other two in the next couple of days, but the one we're going to talk about today is simply where we take it and we slide it into another position. Okay, pre-image, image. All right, before the change, after the change. Next, we often use what's called prime notation to help us see relationships between a pre-image and its image. So here we've got a pre-image in green, and its image after the translation is written here in blue. And in order to help us see the corresponding angles and sides and so on, we very often just use from polygon KLMN. If that's our pre-image, we'll often call our image K prime, L prime, M prime, N prime, just to help us see the corresponding angles and how the figures line up. Okay, because this will be especially important as we start to do reflections and rotations. Translations, they're a little easier. Okay, but I want you to see prime notation. K, K prime. So what is a translation? All right, a translation is a transformation that maps all points of a figure the same distance in the same direction. Okay, let me get you a little idea of what we're doing here. Let me put a little purple line here. Okay, this direction is going to be defined by this right here, this XY thingy. Okay. When we write it in notation like this, that XY is going to tell us how much we move over, X, and how much we move up, Y. All right? So, in other words, I'm going to take point K and move over, about yay far, and up about yay much, and I end up at point K. Now, I want you to notice that the same thing is going to happen from L. Move over by that much. Up by the same amount. Where did I just take that? Okay, up by the same amount to get from L to L prime. Same thing's going to happen for m to m prime. Let me grab that. 2. Okay. You guys get the point. What we're doing here is taking the same distance over. There's m. Same distance up in all of these cases to get from each of these points in the pre-image to the image. Okay, that's distance. Whatever is over in the x direction here, that's what I'm going to put here for the x. And whatever we move up in the y direction, this distance here, that's what's going to go here for the y. Okay, several really important things are going to happen here. Okay, notice that all the distances are going to be the same. So KL, the distance here to here, is going to be the same as K prime L prime. Okay, and same with all the other 4 sides. Same with all 4 angles. Angle K and K prime will be congruent, angle L and L prime, etc., etc. So side lengths and angles are going to be maintained. Okay. Notice also, really important stuff right here, is that the distance from K to K prime is going to be the same as the distance from L to L prime and N to N prime. All 4 of those distances also have to be exactly the same. In addition, since the direction on all of those is the same, those 4 lines are parallel, 4 red lines. Okay, so that's what happens with the translation. Let me show you what we do with it. So here we go. What are the vertices? Here's triangle PQR. What are the vertices of PQR when we translate it over 8 down 3? Okay, well, nice and easy. We're going to count over 8 down 3 and put P prime. For Q, we're going to go over 8 down 3, find Q prime. And same with R. We're going to go over 8 down 3, find R prime, connect the dots, and we have a nice, pretty image from our pre-image of PQR. Okay, now that might have been cool to do that the way we do it, the way we did, but I want to show you something else. We can also take the coordinates. P is at -3, 6, right? Look what happens. I can just add 8 to -3 and I get 5, right? And I could say take -3 from 6 and I get 3. So just by combining the x-coordinate with the rule on the x-coordinate side and the y-coordinate with the rule on the y-coordinate side, we can find the coordinates of our image. Make sense? Okay, let me clear those annotations off. All right, so if Q is at -1, 3, once again, I just want you to notice that I can add 8 to the -1, and I end up at 7, and I take away 3 from the 3, I end up at 0. I know Q prime is at 7, 0, without even drawing a picture, just by looking at the coordinate and the rule that happened to it, okay? All right, now let's try another one. I'm going to get rid of all this stuff because we're trying a clean, fresh problem here. Okay, so over here on the right-hand side, XYZ has points at 3, 1, 6, 4, and 5, -2. What are the vertices after the translation? Option 1, of course, we can graph it. There's 3, 1, there's 6, 4, and there's 5, -2. Okay, connect our dots. Make triangle Q, X, or sorry, XYZ. Okay, so if that makes us feel better, we're good to do that. We have X, Y, and Z. Once again, we can just count how much we go over in this case. Make it blue. All right, I'm going over by -10 down 7. So that puts me over here at -4 and about -3 for y prime. Okay, for x, I'm going over 10 down 7. There's x prime. And for z, I'm going over 10, down 7, puts me down here, for z prime. Okay, and there we go. There's x, triangle x prime, y prime, z prime. Oops. Okay, makes sense? All right, now, quick note, remember, we could have just done it by taking 3 minus 10 to find x, the x-coordinate of x prime, taking 1 minus 7 to find the y-coordinate. Okay, so in all of these cases, we can just take each of the coordinate points, like x, 3, 1, and do our minus 10, minus 7 on all of these to find the coordinates of the image afterwards. Okay, so we can do it by graphing, or we can do it by adding up each coordinate with its translation rule here. All right, and I think that's a lot easier, so hopefully we're working towards that. All right, second kind of problem we'll have. Write a rule that maps pre-image ABCD down here in red to the image in the blue. All right, notice that we can just basically here again count. I see I'm going over 2, going over another 3. So I go left 5 and I go up 9 to go from A to A prime. I'll find the same thing from D to D prime and so on and so on. So our rule looks like this. Okay? Finally, let's see if we can do this without the graph now. If FGH has points here, 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 F prime, G prime, H prime has points here, 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 what's our rule? Well, I notice that every x coordinate changes by, and that goes to that, by adding 1. Negative 8 to negative 7, add 1. 2 to 3, I added 1. And the y side, erase all that. The y side, I see I go from negative 9 to negative 3, add 6. 2 to 8, add 6. 0 to 6, add 6. Therefore, my rule must have been translation up 1, over 1, right 1, up 6 to go from FGH to F prime, G prime, H prime. Okay. Finally, a composition of transformations is one transformation after another. We will, each one, the second one will be done on the image after the first translation. Okay, so composition of the vertices of the composition in which T negative 2, 9 negative 2 on ABC is followed by transformation negative 5 negative 4 on A prime, B prime, C prime. Okay, pause it, and basically here's where we're going with it. I'm going to go every point over 9 and down 2, B prime, A prime, over 9 down 2, and C prime over 9 down 2, and we have A prime, B prime, C prime. Okay, now we're going to do a second transformation. All right, and make it negative 5, negative 4. So each of these negative 5 down 4, down left 5, down 4, and left 5, down 4. A double prime, B double prime, C double prime. Okay, that's a composition of transformations. Now I want you to notice one thing, that we still maintain size and distance in all of these cases. We could have simplified this guy by looking at our total amount of change. The total amount of change is 9 minus 4, or 9 minus 5, or 4. Negative 2 minus 4 is negative 6. So the transformation in going from A prime, B prime, from ABC to A double prime, B double prime, C double prime is actually given by the numbers that are over there in that other composition. Okay? In other words, I went over 4. Didn't want to do that. Over 4. Down 6. Over 4, down 6. Over 4, down 6. Alright? Because I also see that from adding up the change happening in those two transformations and the sum coming out right there. Okay? Alright. Hope that makes sense. Hope this is shorter than 20 minutes. I will see you later.